Now I am starting that lab activity here. Actually, here in the previous lab activity, we have decided the focal length of the lens by the calculation using the lens formula 1 by f equal to 1 by v minus 1 by u. What I got, f equal to yesterday equal to 60, v equal to 60. I got it is 30 centimeters, right? So that same lens I am going to use for this activity number 2 here. Practically what we are calculated the focal length of the lens in the lab activity, that same lens I am going to use here, right? With that we are deciding that focal length of the lens is depending on the surrounded medium or not. Here in the activity number 2, what we are going to decide that what is the aim of our activity. Already we have got the focal length of the lens in the lab activity is 30 centimeters. Now I am using the 30 centimeters focal length lens in this activity, right? Then I will use that lens in the different mediums. What happens to the focal length? That I am going to decide. So here, to prove that the focal length of the convex lens will depend on the surrounded medium, right? So is it going to be increase or decrease when we kept that in the water? So you know, according to your 9th class knowledge, refractive index of the medium comparing water to the air, who is having greater refractive index? That means which is rarer medium, which is denser medium. Air refractive index is 1.0003 and water refractive index is 1.33. Who has greater refractive index? It is water. So what happens to the focal length of the lens if you dip that into the water? That is our aim. So here focal length is going to be increase or decrease or remains same. That we have to decide. So here I am assuming f maybe remains same or f are going to be increase or it is going to be decrease. So here focal length of the lens in the water is equal to the focal length of the lens in the air, or that focal length of the lens in water is greater than the focal length of the lens in the air, or that focal length of the lens is smaller than the focal length of the lens in the air. So in this, which is correct, that we have to decide here. To conduct any lab activity, we required a few materials here. Then what are the required materials here? Here the required material according to your aim. What is required first? I required a lens, that is double convex lens with the non-focal length. Already I decided that focal length of the lens is 30 centimeters. Is it clear? In the previous lab activity, I have decided the focal length of the double convex lens is 30 centimeters. So remember that the focal length of the lens in the air is 30 centimeters. Then I required one beaker. I required a beaker, right? So glass beaker you have to take, transparent it is. You required water because to change the medium. So you required water. Here to hold the lens we required lens holder. So here circular lens holder required and object is required. So here I is a object. I am using a stone, black colored stone. This is object for us to see this object through the lens. Black colored stone is required. Then to hold the lens I required a lens holder. So this is the lens holder, circular lens holder it is. To measure the focal length you required a ruler. So you need a 1 meter scale here, right? So these are the minimum required materials to conduct this activity. Hypothesis. What is your hypothesis here? For this purpose, maybe the focal length of the lens is depending on medium. So this is our assumption. Maybe you will get the satisfactory result or quite opposite, we don't know, but we have to verify what our assumption is made by you, that is correct or wrong. What are the precautions you may take here? How do you decide the focal length? By viewing the object through the lens, right? So here that distance we have to measure. At what distance from the object you are keeping the lens, that distance you have to measure. So measure that accurately or somewhat possible up to that extent, right? Then view the image through the lens properly. Here, if you are viewing something object through the lens, automatically it becomes blur. Try to view the sharp image through the lens. So these are the precautions here. One more precaution is there, that is here beaker height. That beaker height should be greater than 4 times to the focal length of the lens, right? Here, what is the focal length of the lens considered here? 30 centimeters. So nearly you required 120 centimeters or at least 100 centimeters of height beaker, right? That beaker height should be equal to 100 or above 100 centimeters. See the second precaution here, viewing the image through the lens carefully to obtain sharp image. So these are the precautions in the procedure. See here in the procedure what I am following the steps to conduct the activity to obtain the result that I am writing in this procedure. First, fix the lens into the holder. After that, just put a table. One more you have to verify. Just I am given a focal length of the lens size 30 centimeters. Do you need any verification or directly believing? We have to verify that. What is the focal length of the lens in the air? That you have to find out first. So in the procedure, first I am writing about the focal length of the lens in the air. Here for that, just on the table I am conducting this activity without beaker, without water, right? Just I required my object here. Okay, I have my object. Put it over the table. Just I placed that black stone on the table surface. Then I have to see that object through the lens, right? So here use that lens which is fixed in the lens holder. Just bring it closer to the black stone as you see here. Then I got this closer to the black stone. Then what to do? Just you have to see that black stone through the lens. Then suppose if your friend viewing that object, then you are observing all the process, right? Then what you will ask, that fellow is able to see the stone or not, right? Ask your friend, is it visible or not? So here what he is saying, it is visible. Actually, with the double convex lens, according to your ray diagrams, where you are able to see that, when you are able to see that, actually double convex lens, it is giving the real image many times. Only in one condition it will give you virtual image. Where it is? Just follow your ray diagrams. Only in one situation double convex lens will form the virtual image. That virtual image only we can see directly. Otherwise that real image only viewed on the screen. Is it clear everyone? Do you have idea this one? The ray diagrams. Already we have drawn the ray diagrams also. Object placed at infinity, real image. Object placed beyond the center of curvature, real image. At center of curvature, real image. Between focus and the center of curvature, real image. At focus, real image. Then only one position is left. What is that? Between pole or optic center of the lens to the focus. See here, when the object is placed in front of a lens between pole or optic center and focus, then you are able to visible that, or simply this one you are able to express as inside focus. Then it forms virtual image. Who is inside focus? Object should be inside the focus. Then only it is able to form the virtual image. Then you are able to view directly through the lens. So here the person is saying, I am able to see that lens. Then it means what? Where you placed that object? Where is the object? It is inside the focus or not? Yes, inside the focus. Then I am moving this lens again. Yes, moved. Then again ask your friend, is it visible or not through the lens? So it is visible, right? Decide that length. Decide the length of the lens, where at what height you are able to see that. What is the length of that? That means gap between the lens and to the object. I am using the scale to know the value. How much it is?
30 centimeter.
Yes. So at 30 centimeters he is able to see. If that object is inside 30 centimeters also, he is able to see. See here. Just it is inside. At that place also he is able to see that. If it is moved away up to 30 centimeters, he is able to see that. What happens if you move that more than 30 centimeters? Right? Here, note on that, as its a focal length, f equal to 30 centimeters. Then slowly move the lens up to somewhat height above 30. Then ask your friend. Not visible. What is the reason here? Why is unable to see? We are not removed that object. It is on the table only, but it is not visible. Reason? Because in this situation, that lens is formed real image. Right? Real image. So here, what is the correct method here? Just you have to move that towards 30 centimeters only. Then that person able to see that. Okay. So that is the required thing here. See, at 30 centimeters he is able to see that length we are decided as 30 centimeters of focal length. Then if it is moved further distance, he is unable to see the stone through the lens. So that is formed real image. So simply in the air you are able to find out the focal length of the lens by viewing the object through the lens clearly. That length is called as here focal length of the given lens. So like this we can decide the focal length of the lens in the air. Just we have to change the surrounded medium. Right? Up to here in this, where is the lens placed in a medium? That means I am asking about the medium. What is surrounded medium here? Around it, what we have? Air. So focal length of the lens in the air I got 30 centimeters. Is it clear? Yes. Then we will go for another one. Here changing the medium around the lens. Then for that just I am creating here water. Okay, so I will take a table. On the table I will put one glass beaker which you are selected more than 100 centimeters its height, or that height of the beaker is 4 times greater than the focal length of the lens. I have to fill this beaker with the water at least 3 times to the focal length of the lens. So water is filled into the beaker. Then what to do? Just drop object into the water. Drop it. What is the object here? Which is object?
Black stone.
Black stone. So now I am dropping that black stone into the beaker. Yes. Just we have to see the object. Right? Okay, directly you are able to visible. Then if you see that object through the lens, what we can see? Its image. Right? So through the lens, are you able to see that or not? Then I will insert lens into the water. Then same person, ask your friend to see that object through the lens. Right? So here, is he able to see that or not? Ask. Right? Here it is visible. That means you are inside the focal length of the lens. Again further height increase above the black stone. Yes, increase it. Again ask your friend, is it visible or not? Yes, visible. So then can we decide this is the focal length? No, maybe it is also inside. Further increase just above the stone. Okay, further increase it. Then again ask him. So it is invisible. What may be happened here? Why it is invisible? Maybe you are maintaining the height of the lens above the stone is greater than the focal length of the lens. In that case, it forms the real image. Real image does not visible. It doesn't visible through the lens. Just we required a screen. So not using the screen here. I want to see the virtual image directly. So just little bit I will move downwards closer to the stone here. Just a little bit down moving. Yes. Again I will ask that person. Okay, it is visible. Right? Just like that you have to adjust the height of the lens to find out exact position above the stone to view the image through the lens. Right? So it is the actual height to visible that black stone through the lens. If you move further above that, what happens? It is again invisible. Right? So that is the reason here to move the lens above the stone here, up and down. Just find out the exact position where he is able to view the stone here. Okay, it is visible now. Measure the height of the lens holder or lens above the stone here using the scale. What is the measurement here? F is equals to, I got 40 centimeters. Then what you can give the generalization here? What is your result? Focal length of the lens in the water, I got 40 centimeters. Right? Here, this focal length I am deciding, guys, focal length of the lens in water. Is it greater than the focal length of the lens in the air or less than the focal length of the lens in the air, or it is equal to the focal length of the lens in the air? What you observed here?
It is greater than.
Then what you are able to generalize here?
Focal length of lens is greater in water
Why
and
it
less
is greater? Why it is greater?
its medium is changed now.
Yes. So simply you are able to give the generalization here. Focal length of the lens depends on the surrounded medium. So I have decided here focal length of the lens depends on the surrounded medium. How I concluded that? Comparing the focal length of the lens in the air and in the water. In the water, the focal length of the lens I got greater value comparing with the focal length of the lens in the air. So that is why I am able to decide here focal length of the lens depends on the surrounded medium. So this is your activity number 2.